So, complex fractions. So what they are, first of all, complex fraction is when you have a rational expression within the numerator and or denominator. So basically a fraction and a fraction. So we got a fraction, and then on top is another fraction, or in the bottom. So it could be in both, one or it could just be one. Typically, the ones we'll do will have a rational expression in both. So to simplify these, there's kind of basically a trick. Simplify, what we do is we multiply by the least common denominator over the least common denominator. I mean, we're allowed to do that. We can multiply anything by 2 over 2 if we want. So we're going to multiply by the least common denominator over the least common denominator. And kind of go from there to simplify it. So for our first one, so on top, so I have my big fraction line. The top, I have 5x over 9y squared. So that's my numerator. And then my denominator, I have 25x squared over 27y to the third. Okay, so I'm going to look at just my denominators right now. On top, my denominator is 9y squared. On the bottom, 27y cubed. So I need to find the least common denominator out of those. So first of all, 9 and 27 for the numbers, I'm going to need 27. Now, out of my y's, I have to have the most number of y's. So it's going to be y to the third. So what I'm doing here is I want to drop out all the bottom, basically. So on top, the 9 and 27, okay, remember this is like put 27y cubed over 1. It's the 9 and the 27 are going to cancel. I'll be left with 3 on top. Y squared is going to cancel so that I'm just left with a y on top. So now, the whole 9y squared drops out. I have 5x times 3y, so 5 times 3, 15. I still have an x, what was there, and then I am left with a y. Okay, now on the bottom, again, this is like over 1 times over 1. So 27y cubed, 27y cubed. Those cancel completely. And I'll be left with 25x squared. Now, if I can, I'd simplify some more. So in this case, I can reduce by 5. So I'd be left with 3 on top, 5 on the bottom. Okay, reduce by 5, reduce by 5. The x on top, use a different color here. X on top will cancel with one of the x's on the bottom. So I'd be left with y on top and 1x on the bottom. So that would be as simplified as I can go. Okay, so that was one where we just had one fraction over another fraction. Now let's get to one that's a little more involved. Okay, so my big fraction line. So on top, I have x minus 1 over x squared minus 4. On the bottom, I have 1 plus 1 over x minus 2. Okay, so this one's got a little more to it. It looks a little bit bigger. So when I look at this, well, I'm going to probably have to do something in the numerator first. That denominator, I can factor that. X squared minus 4. When you see that little flashing red light should go off, that I can break this into x plus 2, x minus 2. Over 1 plus 1 over x minus 2. Okay, so now I'm going to try to find my least common denominator. I'm going to look at all the denominators, and I'm going to include all of those, what I'm going to multiply by. So I'm going to need an x plus 2 and an x minus 2 on top. Now I look at the bottom, basically, is there anything else I need? Well, there already is an x minus 2, so that is already covered. So that should be good. If I multiply by x plus 2 over times x minus 2, top and bottom. That should drop out all the denominators within the complex fraction. Okay, so now the top. Again, remember, that's just like over 1. X plus 2 cancels, x minus 2 cancels. So I'm just left with x minus 1 on top. Okay, now on the bottom, now this is a little trickier because I have two things going on here. This has to get distributed to both parts, two terms here. So when I multiply 1 by the x plus 2x minus 2, it's just whatever it is, x plus 2x minus 2. Okay, that doesn't change. 1 times x plus 2x minus 2, just bring it down. Okay, now, in the second term, the x minus 2 cancels. 1 times x plus 2 is x plus 2. Okay, so now I'm going to do a little simplifying here, see what happens. So on top, I still have x minus 1. On the bottom, if I FOIL that, x squared plus 2 minus 2 is going to drop out, so x squared minus 4. Plus x plus 2, bring that down. So I have x minus 1 over x squared plus x. The minus 4 and the plus 2 will become a minus 2. And looks like I could try to factor that. Let's see. Well, it's going to be a 2 and a 1. Plus 2 and a minus 1. Yep, that's going to work out. X plus 2x minus 1 is how that factors. So notice, x minus 1 cancels, and I am just left with 1 over x plus 2. So that simplified down quite a bit from what it started as. Okay, so that was a tricky one. So the key is, though, look at the denominator. Basically try to drop out all the denominators. That's how I like to think about it. The other tricky part, make sure if there's on the bottom like this one, two terms, you have to multiply that least common denominator by both terms. Okay, let's do one more. Now this one is going to look a little different when we start, but when we rewrite it, it's not going to be that different. So let's say I have on top 3x to the negative 1 plus, in parentheses, 2y to the negative 1 all over x to the negative 2. So right now, this, looking at it, you might think, well, this isn't a complex fraction. It's not a fraction and a fraction. But those negative exponents, I'm going to rewrite this. X to the negative 1, remember that's the same as over x to the positive 1. And then in this case, the 3 would stay on top because just x is to the negative 1. So that's how I would rewrite 3x to the negative 1. Now the next one, notice the 2 is in parentheses. That's also to the negative 1. So this whole thing goes to the bottom. 1 over 2y. And then on the bottom, now this is going to be 1 over x to the positive second. Okay, so right now all I did is I rewrote my negative exponents, brought them down into the denominator to make them a positive exponent. Okay, so now I need to look and do my step of multiplying by my least common denominator over least common denominator, which in this case, if I'm looking in terms of my numbers, I'm going to need a 2. My x's, it looks like I'm going to need x squared, and then I've got a y. So if I multiply by 2x squared y, that'll drop out all of my denominators. So for my first one, and I think for this one I'm going to show you how you could write it out in a bit more detail, especially if you have two terms, like in this case on top. So you could have done this one with the second too if it helps to write it out a little more detailed. So this is 3 over x times 2x squared y over 1 plus 1 over 2y times 2x squared y over 1 all over 1 over x squared times 2x squared y over 1. So there's kind of a more detailed way to write it out, if that helps you stay organized. Okay, so my canceling now. first one, x is gone. The squared is gone. So 3 times 2, so this is going to be 6xy. Plus, next one, 2's cancel. Y's cancel. I'm just left with x squared. Over, next one, x squared cancels. So I am left with 2y. And it looks like I could factor out an x on top, but it doesn't look like it's going to get me anywhere. It's not going to lead me to be able to cancel anything. So I'm just going to leave it how it is. So now it's just a regular rational expression, not a complex one.